Particle P moves in a straight line with acceleration sine omega t meters per second squared at t seconds, where omega is a constant. Initially, the particle is at rest and its displacement from a fixed point O on the line is 1 meter. Find the velocity of P at any time t. So we know that velocity is the integral of acceleration, which in this case is integrating sine omega t with respect to t. Now sine integrates to negative cos, so we could write this as c take away, that will be cos omega t divided by omega. That's just the chain rule reversed because we're integrating. And we know from the information up here that v equals 0 when t equals 0. So 0 is equal to c take away, now cos of 0 is 1 over omega, and that means that c is 1 over omega. So v is going to be 1 over omega 1 take away cos omega t. Okay, we now want to find the displacement of P from O any time t. So x, well, that's going to be the integral of v. So we're integrating 1 over omega take away cos omega t over omega dt. So that's going to be 1 over omega t. Remember, 1 over omega is just a constant. And then when we integrate cos, we get sine. So that is take away sine omega t over omega squared plus a constant. Now we're told initially the particle is at rest, so that's the v equals 0 when t equals 0, and its displacement from a fixed point on the line is 1, so that's x is equal to 1 when t equals 0, and so if we substitute those in, we get 1 is equal to c, because sine of 0 is 0 and 1 over omega t would be equal to 0. So c is equal to 1, and therefore x is going to be 1 over omega t take away sine omega t over omega squared plus 1. Find the value of t when P next comes to instantaneous rest. Remember, it's initially at rest. Well, if we look at velocity, we're going to need 1 minus cos omega t to be equal to 0. Now that happens when t is equal to 0 because cos of 0 is 1. So we want the next time that cos omega t is equal to 1. And that would mean that omega t is equal to 2 pi. Cos of 2 pi is equal to 1. And so t would be equal to 2 pi divided by omega. Find the distance travelled in the first 2 pi over omega seconds of motion. And note that that is the first time that it's at rest after the t equals 0, the initial point. So it's travelling all in one direction during this time. And so what we could do is calculate x of 2 pi over omega. So that's going to give us 1 over omega, we're substituting in here, 2 pi over omega, take away sine of omega times 2 pi over omega divided by omega squared plus 1. And so that is 2 pi on omega squared. This one is just 0 because it's sine of 2 pi plus 1. So since it started at x equals 1, the distance would be equal to 2 pi on omega squared.